All right, so for the next question, the answer is C, 8.16 molar. So just take a few minutes and try to solve that for yourself. And if you get stuck or aren't able to get the answer, just unpause and work through the question with me. So the question says, a 6.36 molal Na2SO3 aqueous solution has a density of 2.31 grams per centimeters cubed. What is the molarity of Na2SO3? All right, so let's look at what we were given. A 6.36 molal Na2SO3 aqueous solution. So what that is telling us is that we have 6.36 moles of Na2SO3 per 1 kilogram of our solvent, which we know is water because of this aqueous symbol or sign. Okay, so this solution has a density of 2.31. So let's say solution density equals 2.31 grams per centimeters cubed. What is the molarity? Of Na2SO3, and let's just remind ourselves what molarity is. Molarity is the moles of solute over liters of solution. So in this case, molarity is going to be the moles of Na2SO3 over liters of solution. All right, so let's see where we should start. Well, we need moles of Na2SO3, and we were already given moles of Na2SO3. So we are all set for our numerator. Now we have to find a way to get to liters of solution. And the only information we were given is that this solution is comprised of Na2SO3 and water, and that the solution density is this. So first, let's just, as usual, draw out what our solution is. Let's give ourselves this container filled with liquid, and this liquid is our solvent, which in this case is water. And our solute that is being added to the water is Na2SO3. So now we know what our solution looks like. From this, what we see is that a solution equals a solute plus a solvent. Now we have to find a way to manipulate this equation in order to get to liters. And the only connection we can see between liters, well, to get to liters, is centimeters cubed, because centimeters cubed is equal to milliliters. So we can get from that to that. So if we can find our grams of solution, we'll be able to find our liters of solution. Now that being said, we weren't given grams of solution directly. So if we find our grams of solute and our grams of solvent, we can add them, find our grams of solution, and get to liters. So we were told that we have 6.36 moles of Na2SO3. All right, oh, let me just also write Now we know what we're trying to look for. Okay, so we have 6.36 moles of Na2SO3. And for 1 mole of Na2SO3, we need to find how many grams we have. So what we are going to do is look at what it is comprised of. We have Na, we have S, and we have O. We have 2 Nas, we have 1 S, and we have 3 O's. So now what we're going to do is multiply them by their molar masses. So for Na we have 2 times 23. For S we have 1 times 32. And for O we have 16 times 3. All right, so 2 times 23 is 46, 1 times 32 is 32, and 3 times 16 is 48. Let's just add all of these together. And we get 126 grams for 1 mole. All right, so let's cancel out our moles. And let's solve for grams of Na2SO3. So that's going to be 6.36 times 126, and that gives us 801.36 grams of Na2SO3. All right, so let's just plug that in. 801.36 grams. All right, so let's find our grams of solvent now. We know that we have 1 kilogram of water. And in 1 kilogram, there are 1,000 grams. The units of kilograms cancel out, and we have 1 times 1,000, which is 1,000 grams of water. Right, so we're running out of space here a little bit. But 801.36 plus 1,000 gives us 1,801.36 grams of solution. All right, and we know that for 2.31 grams of solution, we have 1 centimeter cubed. And we know that 1 centimeter cubed is equivalent to 1 milliliter. Cancel out our units, and we know that there are 1,000 milliliters in 1 liter of solution. All right, so just solving for our answer here, we get 1801.36. Oh, no, we get 2.31 times 1,000, and we have 1801.36 divided by 2310 gives us 0.7798 liters of solution. All right. So now we have liters of solution, and we have everything that we need to solve for molarity. So I'm just going to rewrite what molarity is, just so that we don't get lost. Molarity is equal to the moles of solute over liters of solution, which in this case is the moles of Na2SO3 over liters of solution. Plug our values in. Moles of Na2SO3 was given, and that is 6.36 moles. Liters of solution we found to be 0.7798 liters. So finally, solving for molarity, we find that we have 8.16 molar. You may also see a capital M. These mean the same thing. These are the units for molarity. So here we have our answer. It matches the answer we were given, and I will see you in the next video.